Structural diagrams. These figures likely illustrates the structural components of a machine learning technique designed to forecast the influence of population growth on the budget of a barangay. It might include various components such as data sources, algorithms, models, and outputs. A class diagram depicts the class's attributes, methods, and relationships among objects in a system. In this context, it will represent the classes involved in the machine learning technique mentioned above, such as for data processing, model training, evaluation, etc. Pseudocode for add resident. This describes the user interface for adding a residence to the system. The pseudocode outlines the steps involved, including loading the residence, displaying the add residence form upon clicking the respective button, handling submission, updating resident information, and removing a resident. Pseudocode for update resident. Similar to the previous interface, this one is specifically for updating residence information. The pseudocode outlines the process of displaying the update resident form, handling error information, and saving changes. Pseudocode for creating funding. This interface likely deals with creating funding, but the provided pseudocode seems to be identical to the pseudocode for adding or updating residents. It may need clarification or correction. Pseudocode for predict Borok population. The pseudocode describes how users interact with the system to predict the population of a neighborhood. First, they can load residence data if they want to add new residents. They fill out a form, then return to the main page after submitting. Similarly, if they choose to update or remove resident, they follow similar steps and return to the main page afterward. This ensures a smooth and straightforward process for users to manage resident data before predicting neighborhood populations. Pseudocode for predict barangay population. This pseudocode outlines the user's interface flow for predicting population of a barangay. It starts with the option to load resident data, enabling users to manage resident information. If users opt to add a new resident, their guide to a form for inputting details after submission, they redirect back to the main resident management page. Similarly, if users choose to update or remove a resident, they follow a similar process, ensuring coherence within the residence management system. This straightforward structure aims to facilitate user interface and ensure a smooth experience in predicting population of the barangay. Pseudocode for predict budget. This pseudocode outlines the user's interface flow for predicting budget of the barangay. It begins with providing users the option to load resident data, which is crucial for budget forecasting. If users decide to add a new resident, they redirect to a form where they can input resident details. Upon submission, they return to the main resident management page. Similarly, if users opt to update or remove a residence, they follow a similar process, ensuring consistency in user interaction. This straightforward approach streamlines and management of resident information before proceeding with predicting the budget of the barangay. Pseudocode for view population. This pseudocode outlines the user's interface flow for viewing population data within a barangay. It begins by providing users with the option to load resident data, which serves as the foundation for population statistics. If users wish to add a new residence, they are directed to a form where they can input the relevant information. Upon submission, they can return to the main resident management page. Similarly, if users choose to update or remove resident, they follow a similar process, ensuring consistency in users' interactions. This straightforward approach ensures that users can easily manage resident information and access population data within the barangay.